Hello and welcome to this section of the TI-89 Calculator Tutor. In this section we're going to explore the capabilities of the TI-89 with respect to its ability to do implicit differentiation. So for those of you taking calculus, this will be something that'll be really exciting for you that you can actually do in your calculator. And prior to the TI-89, actually I wasn't aware of any calculators that can do this symbolically, so it's really kind of cool. So most of you guys have taken calculus, you know what a derivative is, you know the rules of differentiation there. So if you have y is equal to some function of x, you take those derivatives just like you're taught in calculus class. Of course, this calculator can do that as well. But implicit differentiation is used when you have a function that's not already solved for y. In other words, you don't have y is equal to some function of x. You have something more complicated. So you might have, y squared plus y is equal to x squared plus 3x plus 4. So or something like that. So you might have something where you don't already have y solved for. You have to use implicit differentiation to solve that guy. So to show you how that works, let's go up to the calc menu, F3. And we're going to go down past arc length. We already covered that. We've covered the Taylor expansion. These inderiv and integral, these are numerical derivatives, numerical integrals. They're very seldomly used there, and I'm going to skip them for now. DE solve we'll come back to later. That's solving differential equations. But what I do want to do is come down to implicit differentiation, and that's actually the last guy on the list. So if you go up from the top, you'll get to D, which is implicit differentiation. Because it is something you do in Calculus 1, it's very important, and it's good that you can check your work. So what you're going to do here is type in a full-blown equation. So it has to be, everything that you want to take the derivative of. So if you go and type in, let's do something very, very simple. Y is equal to x squared. Now you all know that you don't really need implicit differentiation to take this derivative, but it can handle it fine. And I'm going to kind of give more and more complicated examples to show you how this thing really works. What you do by hand if you're taking this derivative is you take the derivative of the left-hand side with respect to x, and what you'll get is dy with respect to x, so dy dx on the left. On the right-hand side, you just take the derivative normally, so you'll get 2x. So I'm just showing you by example that you can actually use the implicit differentiation function to take any derivative you want in this calculator, including cases when you need to do it implicitly. Now, one thing you need to add after you put the function here with the equal sign, you have to put the independent variable, which is x, and in the dependent variable, which is y. So this is basically telling the calculator, do implicitly differentiate this function. We're trying to find dy dx. That's what we're trying to find, the derivative of y with respect to x. The independent variable is x.